Question number 8. To give me a bit of space at the bottom, I'm going to do that horrendous thing of writing an answer over the question. I do apologise, it's appalling. I'll write myself a strongly worded letter. So plugging into the numbers into the equation, we'll get sine 1 times by 273.2, subtract 213 lots of cos 1, divide both sides by sine 2t sine t and substitute in again. That will give us our value of a. Plug that into your calculator, and to 3 sig figs, that's 150. For part B, so first I'm going to plug in the value that we just calculated for a, and then I'll put it into standard linear form and use an integrating factor. So dividing everything by sine of t, we get dx by dt, subtract x, and then cos of t over sine of t, or cot of t if you prefer, is going to be equal to 150. The sine t's cancel, so we're just left with sine of 2t. Then the integrating factor, so we know e to the power of the integral of cos t over sine t, that's going to be e to the natural log of sine t, with the minus out the front. So that's ln of 1 over sine t, or if you prefer, ln of cosec t. Cancel the ln's with the e's, and so we get cosec t. So multiplying everything in our equation by cosec t, we get cosec t of dx by dt. Subtract then x cot t cosec t is going to be equal to 150 lots of sine 2t times cosec t. Just tidying that up a little bit now. So cosec t times dx by dt, subtract x cot t cosec t is going to equal to sine 2t to sine t cos t, so it's going to be 300 sine t cos t cosec t. The sine t and the cosec t will cancel, so we get 300 cos of t. Then, recognizing the left-hand side is the outcome of the product rule of differentiating x cosec t with respect to t, we can integrate both sides. 300 cos t goes to 300 sine t plus c. It tells us in the question that when x is 213, t is 1. So we can substitute that in to calculate our constant of integration. Subtract 300 sine 1 from both sides. C is 0.687. Then multiplying both sides by sine of t will leave us with x on the left hand side. We equal 300 sine squared of t. Sine times cosec will cancel, plus the 0.687 sine of t. And that is our particular solution. Okay, for part C, we can substitute substitute x for 0. So 0 equals 300 sine squared t plus 0.687 sine t. Factorize out the sine t. And that tells us actually that the values of t will be 0 or pi within the range. And so I'm going to take, obviously, zeros at the start. So I'm going to take t to be pi, 3.141, etc. So that's 3 hours, 0.14 of an hour is 8 minutes. It's 8.49 minutes or something. So the time on top of 10 o'clock will be 10 plus 3 hours and 8 minutes. For part D, we can set our x to be 300.68. And then solve it. I'm going to use a calculator. So using Casio's equation solver setting, you can just type the equation in as it is and do all the heavy lifting for us. So 300 sine of x squared plus 0.687 sine of x is equal to 300.68. When I solve that, we get 1.57 to 3 decimal places. So that's my value of t. Now, that is pretty much exactly half the time that it took him to get up and down, which suggests that this model isn't particularly accurate. If you're climbing and walking up a hill, you wouldn't necessarily expect to take the same amount of time to get to the top as you would do back down again. You probably get back down faster. So my limitation is that equal time for going up the hill as down is likely to be different.